बैठो, ऊपर बैठोगे? अरे बैठो एक बार। बदमाशी करोगे? नहीं, ऊपर बैठोगे? बदमाशी करोगे? नन्ना नहीं, बदमाशी करोगे? नहीं।
Hi everyone. Can you hear me? Hello.
Yes, sir. Good evening, sir.
Hi, good evening. You can hear me, right?
Yes, I can hear you.
Yeah, sorry for being late. Shall we begin?
Yes, sir.
Oh. How's your Saturday going? Sab ठीक ठाक?
Yes, sir. As usual at home.
At home? Okay. Well, I'm also at home, but with few problems. Got a call from the vessel. Their
Okay.
purifier is blown up.
No, sir. Everybody is safe, sir.
Yeah, yeah,
Everybody.
everybody is safe. Yes, yes. Everybody is safe. The
Okay.
purifier had blown up, and there is no alarm as such, nothing. It's only when somebody went for a round, they found the purifier is blown up.
Okay.
What safety did you have on the purifier?
So we have alarm,
What
vibration
ki-
alarm.
what kind of alarms did you have so the purifier remains safe?
So leak off alarm we have. Overflow
Okay.
alarm we have. And the overloaded alarm also we have.
Mm-hmm.
And this water supply is not going. Just the minor alarms also have that PLC.
Okay. So when the
And few.
purifier actually blows up, when the
Yes,
purifier blows up, before that, there should have been an alarm, right? What is that alarm?
the overload alarm system, sir.
Overload alarm
For motor, sir.
or motor. That means the purifier should stop. It should not blow up then. If the motor gets overloaded, then the
Yes.
purifier should trip and stop. Correct. When it
Yes.
stops, it will not blow up. It will blow up when it is spinning at that same RPM and there is nothing to stop it. Correct.
The blower maybe the holding that bolt that maybe not connected properly.
Hmm. So basically, there is a vibration sensor on the purifier, right? Not every purifier has it, but
Distribution
normally Alpha level,
alpha level level खाली है आपको.
Westphalia, Alpha level, all these purifiers, they have a vibration sensor. Unfortunately, this purifier was a very old one. It is an old vessel with 18 years age, and there is no vibration alarm. So it's just broke, and that is it. Nobody knew.
Maybe the oil spill is there. The purifier room also.
Sorry?
Oil spill also there, sir.
Yeah, it is there, but there is a purifier workbook or a log or a PMS entry, and it says they have checked all the alarms. But the recent finding is that nobody was checking that alarms, and none of the alarms were rightly working, and the time delay was increased because of I don't know what reason, and yeah, it did not trigger.
So on my last ship, I was using this BRSO from this Houston. That oil
Hmm.
is very good. My oil
Yes.
got this back type, solid back type.
Hmm.
So
Normally, oil in
most
Houston,
purifier got.
Newark, yes, yes. Houston, Newark, and all these places, they are actually very bad quality of fuel oil. So when I say the fuel oil quality
Very,
is bad, what is bad in the fuel oil quality?
this is the catkin, not catkin, so what we call it. तो वो मतलब टेम्परेचर अगर मेंटेन नहीं करते हैं ना सर उसको
Hmm.
अगर एक पर्टिकुलर टेम्परेचर के ऊपर तो सर वो बाइंडिंग छोड़ देता है सर उसमें तो क्या कहते हैं सर उसको
अनस्टेबल
वो
टाइप ऑफ
स्लज स्लजिस फॉर्म में आ जाता है मतलब अनस्टेबल हो
normally,
जाता है उसको स्लो हो गया.
Too much foaming, sir. Yes.
normally what happens, the sludge accumulates in the purifier. See, if you run a purifier with the diesel oil and the same purifier you run it with the fuel oil, correct? Then which will form more sludge? Which case the purifier will,
Diesel oil.
it will form more sludge in diesel oil?
In sludge, in case, sir, every time discharging the same oil, sir. Not.
The
No, I'm asking.
sludge generation is heavy oil will more than the diesel oil.
Correct. And that is right. In heavy oil, the sludge will be more. In diesel oil, the sludge will be less. But the question is, which parameter in heavy oil will form sludge in the purifier? When you have the analysis report, right? You get the report, many things are there. But which parameter exactly will tell you that this is going to form sludge?
I think there is
CCI
optimum viscosity.
CCI value, sir.
CCAI. What is CCAI?
Carbon cation aromatic index, sir.
Carbon contrastion aromatic
Carbon
index.
carbon
Does it have any relation to sludge? It doesn't.
Yes, CCAI numbers.
CCAI number nahi hai. CCAI number will affect your combustion properties. It will not affect the sludge forming properties. See, contrastion carbon aromatic index. Aromatic index is basically affecting your combustion quality. It will not affect how much sludge it is going to form. So the right answer is TSP. It is called total sediment potential. If the total sediment potential is high, then that means it will have more sediments, correct? It has more sediments in suspension. So when you leave the oil just like that in the tank, it is going to, this heavy sediments, they are going to settle down in the bottom, and purifier is sucking from the bottom. So the more sludge will be in the purifier when your TSP is high, right? So that is called total sediment potential. What is the limit? The limit of TSP is about 0.1. Okay. And anything above, let's say 0.1, 0.2, that is the normal case that you see. Anything above 0.4, 0.5, you should be alert. You should ask your engine room staff to drain it more frequently than it is normally done. Yes? Shall we proceed?
Yes, sir.
So when the CCI is high, it is a different case. It will affect your combustion qualities. How it will affect? It will affect by causing a ignition delay. So when there is a direct relation between CCI value and the ignition delay. There is no formula established as yet, but normally by experience I can tell you that if your CCAI is high, then your ignition delay is also higher. That means you can hear a knocking sound. It is highly possible. Okay. What is the way to counteract it? That is where the maker has given you FQS on the engine, fuel quality setting. So you are adjusting your fuel quality setting based on your CCAI. That is how it happens. Okay.
Yes, sir.
And the limit of CCAI is 870.
870 to 87. 870 to 87.
No. See, we are mixing two things here. 8027 or 8217, it is the ISO standard. Don't confuse with that.
ISO standard, yes.
ISO standard is different, 8217 and all that is different. But CCAI value जो है, the limit of CCAI is 870, 870.
Okay, sir.
Okay. Beyond that, you will have problems.
problem.
So the maker of the engine says the engine can handle a value up to 870. Yes. But in practicality, what happens? Anything beyond 850, 855, you already see that ignition delay is increasing. That is the practical aspect I'm telling you. Okay. So अब वहां पे थोड़ा alert हो जाओ. So as a management level engineer, purifier तो खोल के बंद कर देंगे यार. But these, if you don't want to open the purifier every day, then you have to understand what your fuel report is saying and what each parameter means. Okay, so that clear understanding you should have. Okay. Now, coming back to the alpha lubricator system. Okay, so we discussed a few basics about alpha lubricators yesterday. Now, to build up on that one, normally, when your cylinder size is up to 80, or let's say, yeah, about 80 bore, so you will have normally one lubricator fitted to each cylinder. Now there are bigger engines with 98 bore, 90 bore, 95 bore, more than 1 meter bore. Then you
Ultra
will
long.
have, if you have G-type engines, you will have 2 alpha lubricators fitted. Okay, so it will depend upon the size of the cylinder. Okay, so
सर
what
उसमें
happens?
पंप भी बढ़ेगा सर, नंबर ऑफ पंप भी यूनिट बढ़ेगा. ऐसे नॉर्मली दो यूज करते हैं तो नंबर ऑफ पंप भी बढ़ाना पड़ेगा, से अल्ट्रा स्ट्रोक रहेगा तो.
नहीं, आप पंप का कैपेसिटी बढ़ा दो ना.
अच्छा.
So normally there are only 2 pumps. Okay,
Yes.
so this is an example of your system with 2 lubricators. Okay, you see each unit in the cylinder liner, it has 2 lubricators fitted. Okay, I will show you another example where only 1 lubricator is fitted, like this one. There are 2 liners you can see, but here you can see that there are only 2 lubricators fitted here. Yeah, so this is another example, and I will show you the cross section. First, let's go through the cross section of how the lubricator works. Then we will go to fit it in the system and then see how the system works. Okay, so this is the cross section of the lubricator. Now, don't get confused with people saying different answers. Okay, so first I will tell you the construction. So here the blue color part, okay, you can see this is the actuator piston. Okay, this blue color part is completely one piece. This is completely one piece and it is called the actuator piston. Okay, the yellow region that you see, it is all filled up with the cylinder lube oil. So this is the lube oil inlet. It goes inside. Okay, and then it the actuator piston makes this actuator piston is fitted to a number of plungers. Now this, you can see this is the injection plunger in green, which is fitted to the blue part, the actuator. Okay, so this actuator moves to and fro. Okay, left and right it moves by the hydraulic pressure, and as it moves, this plunger also reciprocates. Okay, so you can see when it goes back, then it sucks oil. Yes, and then when it moves forward, then you can see this is a non-return valve. It pushes the non-return valve, and this is the discharge to the cylinders. It's a very simple construction. Okay, so moving in the discharge stroke, discharge is done by the hydraulic pressure. So hydraulic pressure is supplied by a 200 bar oil. It is a separate system. This is the case of a ME engine, where the 200 system oil supply is there, and it goes here into the solenoid. The solenoid, as it opens, then it will go to the actuator piston, and then it will try to push it forward, and then the plunger will also discharge. And when the plunger discharges, then you have discharge into the liners. Okay, so that is the actual construction. In the return stroke, how is the return happening? With the spring. So there is a spring here. So that is the return stroke. Okay. So that is the very simple mechanism of alpha lubricator. Now you see what are the accessories here. So one accessory is this position sensor. Okay, it is telling you that the piston is actually moving. Okay, it is telling you the piston is actually moving. When there is no movement of the piston, it will give a failure alarm. Okay, so that is why that proximity sensor is there. Is that understood clearly?
Yes, sir. He will
Okay.
decide the injections.
Yes, so this is one, and this is the solenoid. Okay, now this solenoid is given. This is electric, solenoid with a spool valve here. That spool valve is not shown here, but there is a spool valve inside. It is, what does the spool valve do? It is a basically on-off control. So it goes here. The oil is waiting there. As soon as there is a solenoid signal, the spool will open and it will go to the actuator. So whatever in the return stroke, if there is oil, then it will go to the back to the supply side again. Okay, it's a very simple construction. Is that understood? किसी को कोई डाउट है इसमें?
सर पिस्टन एक्सियल पिस्टन हॉलो दिया सर, इसमें हॉलो क्यों दिया हुआ है?
पिस्टन
ऐसा हॉलो दिया हुआ है ना सर,
कहाँ पे?
तो एक्चुएटर पिस्टन जो है सर वो,
हाँ हाँ,
तो वो किसने दिया है?
वो बस बैलेंसिंग के लिए है. That has no effect on the how you call that, the operation.
ओके.
So the construction is very, very simple. Okay. Now there is one very common confusion in the market. Okay. Where is this lube oil coming from? Okay. So that is the question in the market. Now people are mixing with two answers. कोई बोलता है नहीं ये गलत है, ये सिलेंडर ऑयल ही है. कोई बोलता है ये सिलेंडर ऑयल नहीं है, this is a separate lube oil system which is happening here. Okay. So looking at this diagram, they start relating to this one, which is not correct. Though the actuator, piston, spring, plunger and everything is same here, there is a difference over here. Okay, इसको आप देखो, सिलेंडर लूब ऑयल इनलेट एंड सिलेंडर लूब ऑयल आउटलेट बोलता है. यहाँ पे क्या बोलता है? System oil supply, inlet and outlet. So basically two different systems. Why two different systems? Because when you have an electronic engine like ME hai, theek hai? So in ME, you know, there is no camshaft. So the work of the camshaft is done by the hydraulic oil. theek hai? There is a hydraulic pressure of 180 to 320 bar. Okay, depending upon the type of ME engine, the size of the ME engine. So let's say यहाँ पे 200 bar बोला है. So 200 bar is correct, and this is hydraulic oil in case of ME engine. That is why you see this is written, specifically written as ME engine. Okay, so this is 200 bar supply oil, whereas if you look at this diagram, this is mentioned as cylinder oil outlet, but it doesn't say ME engine, right? It is for other engines which are mechanical like MCC, KMC, SMC, LMC. MC type of engines में ये है, because there is no separate hydraulic oil. So instead of having a hydraulic oil supply, cylinder oil, lube oil itself is pressurized and it is supplied like this. Okay. So if you have a mechanical engine, you will have this system. If you have a ME, then you will have this system. Is that clear?
Clear, sir.
No doubts yet? Okay. So, होता क्या है normally here on this side, on the back of this actuator, ये जो solenoid का जो connection है, यहाँ पे एक red color का LED रहता है. Okay. So whenever this one is sensing a movement, whenever this proximity is sensing a movement, then this LED light will flash. It is a red color LED light. It means that your lubricator is pumping. So whichever the pumping stroke is, usme your lubricator will, you know, it will flash saying that lubricator is moving. So the next time surveyor asks you, how do you know just by looking at the lubricator that it is functioning? So you will look at the number of flashes. Okay. So if it is flashing, it is working. Okay. I mean, at least the actuator is moving, that we are sure. Okay. Now let us look at the system part. Okay. एक single lubricator को ले लेते हैं. Okay. Now this is the case of a ME engine. Okay. This is not a mechanical engine. This is ME engine. This is easier to understand and easier to draw. So I will suggest, if somebody is asking you to draw the system diagram of a alpha lubricator, you better draw this, and no need to draw the replica. You just draw this part, one section only. For one cylinder only, you can draw and finish it. It is a block diagram, very easy, right? So look at what is happening now. Here is the lubricator. Okay. Now it is supplying to this cylinder. Okay. How many quills it is supplying?
8.
8 quills. So the discharge of the lubricator is into 8 quills. So how many pistons are there? How many plungers are there in this
8,
lubricator?
sir.
There are
Every
8 plungers.
every quills have a separate piston.
Correct. So that is clearly understood. If you look at this one, this is a cut section. That is why it is showing only one plunger. But if it is, you try to imagine the 3D diagram, then it will be plunges all around this. Okay. Okay. So there is lubricator supplying to 8 quills. So that problem is solved. Where is so this is the discharge. Where is the suction? The suction is coming from cylinder oil service tank. So it is coming here.
Through pump station.
There is no pump station here. Okay.
Here, sir, here not have, sir. But maybe, sir, pump there have, sir.
It depends. It depends again on this system. You may have a pump, you may not have a pump. Okay.
So
but
in ME, sir, no have pump, sir. In ME, sir.
There are MEs with no pump, but there are MEs with pump also. So I don't want to confuse you. By default, to satisfy the surveyor, you put one pumping station there.
Yes, sir.
Okay. क्योंकि सर्वेयर को नहीं पता यार, वो लोग अल्फा लुब्रिकेटर
बिना पंप नहीं है कैसे होगा.
तो वो ग्रेविटी का 9.81 मीटर पर सेकंड वो लोग को समझ में नहीं आएगा, तो एक पंप उसके आत्मा के शांति के लिए बना दो. ठीक है.
सिलेंडर से पंप में, पंप से फिर lubricator. Yes.
Long time ago, when I gave my class 4, it took me some real patience to tell the surveyor that I did not have a camshaft in my engine. He told me it is not possible. So that was back in 2006 or 7, I don't remember. It took me real guts to tell him that bhai nahi hai camshaft. and his mouth went like, यार तुम क्या बोल रहे हो? हाँ, so he denied it.
Camless.
Then I had a backup ready. I know that they will not accept it. So he asked me to draw the maneuvering diagram of your engine. So it was a ME engine, but the problem is maneuvering diagram is completely different. So I understood that this fellow is not understanding. So I had a backup of a ME engine का maneuvering diagram था, वो मैंने बना दिया चुपचाप. वो बोला देखो इसमें तुम कैमशाफ्ट दिखा रहे हो. मैं बोला हाँ सर मेरी ही गलती है, अभी मैंने ठीक कर दिया है. तो ही सेड मी या ओके, नेक्स्ट टाइम डोंट रिपीट.
जैसे पास हो जाए वैसे करेंगे सर.
बस बस. So, see, you may be more intelligent than the surveyor, but again it is up to him to understand, right? To accept the answer. हमें वो करना है, that is the key. Okay, so यहाँ पे cylinder oil service tank है, and it is going here, and it is straight away supplying to the lubricator. And this connection that you see, ये जो inlet है, that is what is here. Cylinder oil, lube oil, sorry, this is ME, right? तो ये है अपना cylinder lube oil inlet. So that is the cylinder lube oil inlet for the lubricator. Okay. Now here you see the feedback sensor. Okay. And the feedback sensor is right here, the proximity sensor. Okay. Now it is giving a feedback where? It is giving a feedback to a multi-purpose controller. What is multi-purpose controller? It is a simple motherboard. अपना पीसी का मदरबोर्ड होता है ना, एकदम वैसा ही. ओके.
तो सर इसमें सर एमसीयू बीसीयू एसबीयू या बीसीयू नहीं होगा सर?
ये सब नहीं है. एमई में वो सब सिस्टम ही नहीं है. एमसीयू, बीसीयू, सीसीयू, वो सब
नहीं
कुछ नहीं है. ओके. सो दिस इज सप्लाइंग टू अ मल्टीपर्पज कंट्रोलर. ठीक है, क्यों नहीं है मैं आपको बताता हूँ, एंड दैट विल बी मोर एविडेंट व्हेन वी डू द एमई क्लास. ठीक है. तो यहाँ पे फीडबैक सेंसर देता है एमपीसी को, मल्टीपर्पज कंट्रोलर को. एंड व्हाट इज दिस, द अदर लाइन व्हिच इज नॉट मेंशन्ड, ये क्या लाइन है ये?
तो सोलनॉइड कंट्रोल कर रहा है सर.
सोलनॉइड से रिटर्न.
So basically आप जब ये एग्जाम में जाओगे ना, तो यू नीड टू ड्रॉ अ एरो व्हिच इज नॉट शोन हियर. ठीक है. सो यू नीड टू ड्रॉ एन एरो लाइक दिस. एक मिनट. सो इसका डायरेक्शन ऐसे बना दो, इन दिस डायरेक्शन, और इसका डायरेक्शन ऐसा बना दो. ओके. सो दिस वन is the signal and this is the feedback. So this is telling the solenoid to open or close, and this is the feedback saying that okay, open and close हो गया है. Input and output.
ओके सर.
ठीक है. This is what you need to draw. All right. Now ये जो hold on. तो
सर इसमें एक चीज सर, एक्यूमुलेटर भी नहीं होगा सर एमई वाला में सर?
होता है.
होता है सर.
Accumulator होगा. And now again it depends on the type of system. अगर आपका सिस्टम, आपका सिलेंडर ऑयल सर्विस टैंक से लुब्रिकेटर तक डिस्टेंस बहुत ही शॉर्ट है, then maybe there is no accumulator. Okay.
सर लुब्रिकेटर सर बेसिक सर बस कंपनसेशन के लिए सर ना, बस कंपनसेशन प्रेशर.
We will come to the accumulator part. ठीक है. एक 5 मिनट में आएंगे. ठीक है. तो पहले सिस्टम समझ लेते हैं. तो ओके, सो ये सिस्टम तो आप समझ गए. नाउ द नेक्स्ट इज हियर. कहाँ गया? सो नाउ वी वांट टू सी वेयर इज दिस 200 सिस्टम ऑयल सप्लाई. दैट इज दिस वन, हाइड्रोलिक सिलेंडर यूनिट. ओके. सो ये जो हाइड्रोलिक सिलेंडर यूनिट है, यहाँ पे 200 बार का सप्लाई आ रहा है, एंड ये lubricator is mounted physically to the हाइड्रोलिक सिलेंडर यूनिट. सो यहाँ पे एक्चुअली कनेक्शन है इंटरनली, दैट दिस इज सप्लाइड लाइक दिस थ्रू इंटरनल कनेक्शन. ठीक
सर ये
है.
200 बार का सर किधर से आ रहा है सर, मतलब ये पंप से आ रहा है सर, थ्रू पंप?
एयर
आई विल
पंप.
टेल यू, मैं बताता हूँ कहाँ से आ रहा है. बस अभी के लिए इतना समझ जाओ कि हाइड्रोलिक सिलेंडर यूनिट जो है, ठीक है, इट इज माउंटेड टू द लुब्रिकेटर. ठीक है, जहां पे सप्लाई आ रहा है एंड वापस जा रहा है. इज दिस अंडरस्टूड?
सर आपने सर दो डायग्राम बताए थे सर, एक में सर विदाउट ये सिस्टम बार वाला आ रहा है, तो उसमें तो 4-5 बार का ही प्रेशर होगा।
किसमें किसमें?
तो जो दूसरा लुब्रिकेटर दिखाया सर आपने, जिसमें सिस्टम ऑयल नहीं यूज नहीं कर रहे हैं, मतलब ये,
हाँ हाँ,
उसमें तो 4 to 5 बार ही प्रेशर होगा ऑयल में। तो
एक
एक्सल
मिनट,
पिस्टन की जो स्प्रिंग होगी सर, वो, तो ये
एक
बिल्कुल।
मिनट, एक मिनट. यू मीन दिस वन?
हाँ सर सर, तो इसमें
बट
4 to 5।
4-5 बार, 4-5 बार क्यों होगा?
सर ये अगर नॉर्मल लूबल पंप से आ रहा है
नहीं नहीं नहीं, यहाँ पे देखिए, यहाँ पे आपका सिलेंडर लूब ऑयल इनलेट एक्चुएटर पिस्टन इज मूविंग बाय सिलेंडर ऑयल ओनली. ठीक है. वेर एज दूसरे वाले सिस्टम में यहाँ 200 बार मूव कर रहा है.
सर, ये देखा है सर मैंने, ये वाला काम किया था, तो 200 बार का दिखा रहा है इसमें। ये तो
हाँ
सर, ये 200 बार के हिसाब से जो एक्सल पिस्टन मूव करेगा सर, 200 बार में ही मूव करेगा ना सर ये तो।
हाँ, करेक्ट.
इसके लिए सर जो स्प्रिंग यूज किया है सर, वो 200 बार से प्रेशर को, मतलब उस क्वालिटी की है, उतना प्रेशर एग्जर्ट कर सकते हैं। इसलिए
ठीक
दूसरा
है.
डायग्राम जो है, तो सर उसमें तो 4 से 5 बार ही प्रेशर होगा।
नहीं नहीं नहीं, 4-5 बार आप इसलिए बोल रहे हो ना कि यू आर थिंकिंग दैट मेन इंजन लूब ऑयल पंप से सप्लाई आ रहा है. दैट इज वाई यू आर सेइंग.
यस सर।
बट ये मेन इंजन लूब ऑयल पंप से सिलेंडर ऑयल लूब ऑयल इन और आउट कैसे आएगा?
तो मैं वही सब पूछ रहा था कि इसके लिए भी पंप दिए हुए हैं सर, अलग से, जैसे उसमें दिए होते हैं।
नहीं, तो इसके लिए अलग से सिलेंडर ऑयल सप्लाई पंप दिया है, जिसका
ओके
प्रेशर इज 40-50 बार.
ओके, वही मैं डाउट रहा था।
हाँ हाँ, दिस प्रेशर इज अबाउट 40-50 बार.
40 to 50 बार आएगा सर, तो 200 बार के
हाँ,
आसपास।
करेक्ट.
तो सर स्प्रिंग टेंशन भी अलग अलग होगा सर, दोनों दोनों यूनिट
अलग
का।
मतलब द
डिजाइनिंग अलग,
component size and design is the same.
डिफरेंट।
ठीक है, but the component strength and the structure is a little bit different.
ओके
ठीक है.
सर। सर एक ये भी जो मेरा पूछा था, ये हॉलो वाला दिख रहा है सर, इसमें मुझे लग रहा है सर, ये जो एक होल जैसा दिख रहा है, मे बी लुब्रिकेशन के लिए दिया हो, कि यहाँ से ऑयल अंदर जाए और लुब्रिकेट करे जब भी मूवमेंट दे रहा हो।
नहीं नहीं, उसके लिए नहीं है.
कि सर एक हॉलो, एक पॉइंट दिख रहा है सर इसमें, देखिए बीच में ये येलो कलर
ये
का।
वाला ना,
हाँ ये
ये
वाला
वाला.
सर।
हाँ, नहीं नहीं, दैट इज नॉट फॉर लुब्रिकेशन. अभी आप देखो, आई विल शो यू द बेसिक साइज. नाउ यू विल टेल मी, यू विल रियलाइज द फैक्ट कि ये दोनों डिफरेंट सिस्टम्स में, दो इट लुक्स वेरी सिमिलर, बट देर इज अ मेजर मेजर चेंज. यहाँ पे देखो, देर इज ओनली 40-50 बार ऑफ एक्चुएशन. ठीक है. एंड हियर इट इज 200 बार ऑफ एक्चुएशन. आप देखो दोनों का एक्चुएटर साइज देखो. यहाँ पे एक्चुएटर साइज छोटा है, इसका एक्चुएटर साइज बड़ा है. कैन यू सी?
यस सर।
बड़ा छोटा क्यों?
सर प्रेशर डिफरेंस करना है।
करेक्ट. नाउ प्रेशर इज फोर्स बाय एरिया. करेक्ट. नाउ इफ यू हैव टू इंक्रीज, क्या उसको बोलते हैं, इफ यू हैव टू पंप एट 50 बार्स एंड मूव द सेम स्ट्रोक compared to a 200 bar system, then definitely you should change the area, right? इसलिए आप देखोगे 40-50 बार वाले का एरिया इज डिफरेंट एंड ये 200 वाले का एरिया इज डिफरेंट. सो कंस्ट्रक्शन में ही उधर चेंज आ गया. ओके. नाउ कमिंग बैक टू द क्वेश्चन कि यहाँ पे HCU से तो जा रहा है, सब ठीक हो रहा है. देन हाउ डज इट फंक्शन एंड व्हाट डज इट डू? ठीक है. नाउ आई विल टेल यू the basic, let's go to my whiteboard. Can you see the whiteboard?
यस।
Okay. Now in a ME engine, ठीक है, पहले हम एक MC बनाते हैं, फिर एक ME बनाएंगे. So I will draw only one unit of MC engine. So let's say this is one unit, one cylinder, okay, and this is one lubricator, okay. यहाँ पे एक सिलेंडर है, एक lubricator है, and यहाँ पे ये this is lubricating the cylinder here, okay. So this is for a MC engine, mechanical engine. So in a mechanical engine, there will be a cylinder oil tank here, okay. From the cylinder oil tank, you will have a pump which is making 40 bar to 50 bar. Normally 45, 47 bars इतना pressure दिखाते हैं, ठीक है. Now what happens is, what did I lose my pen? Okay. Now this 40 to 50 bar is supplied to the lubricator, okay. And this same lube oil is actuating the actuator piston, and the same lube oil is also being pumped to the cylinder. Is that understood? Any doubts here? This is a MC. Any doubts here?
No, sir.
Okay. If I will continue, if there is a doubt, just raise your hand. I will draw a ME, one cylinder. So in ME, there is no camshaft. So this is ME. Okay. Here also, you have a lubricator. But what is the difference? See, here you have fuel pumps and the exhaust valve actuator. But then it has nothing to do with your lubricator. Okay. Lubricator is running independently in this case. It is running complete by a hydraulic pressure, and that is it. Whereas this is being run by your cam. Correct? That is, this is being run by your camshaft, the fuel pump and the exhaust valve actuator. But in a ME engine, you have the lubricator, you have the fuel pump, you have the exhaust valve actuator. All the three, they are being actuated by hydraulic pressure, the same hydraulic pressure. Okay. All right. Is that clear? Is that clear?
Yes, sir.
Now,
Yes,
since
sir, clear.
all the three are being actuated by the same hydraulic pressure, they are mounted on a common block, a common hydraulic block. Okay. This block is called HCU. This is HCU. It stands for hydraulic cylinder unit. Okay, they are mounted on the same block. This block gets a hydraulic pressure of, let's say, 200 bar from a hydraulic pump. So here is the hydraulic pump. like this. हाइड्रोलिक पंप का सक्शन कहां से आता है? It comes from main engine lube oil pump. So this is the main engine lube oil pump. Okay, this is taking from your main engine sump. From main engine sump, and then it is supplying to this place. Okay, and then it is branching off to your bearings, your thrust bearing, and your crosshead, telescopic pipe, and so on. But then it is also branching off to this line, and it is going supplying to HCU. Is that understood?
Yes, sir.
Now, what about the cylinder lube oil? Cylinder lube oil is here. Likewise, you will have a cylinder oil tank. Okay, this cylinder oil tank, let's say this is the lubricator. So it is connected to the lubricator like this. Okay. Now the same pressure, it activates the fuel pump, exhaust valve actuator, and the lube. So actuation is by a separate oil, whereas the lubricator in and out is here. Okay. And then this lubrication goes to the main engine. So can you distinguish between the ME and the MC setting? It's a different system, right?
Yes.
So that is the difference in the system of a MC and ME.
सर एमसी में तो पंप का प्रेशर तो 45-46 होता होगा सर बार.
45 to 50 बार रहता है.
Yes.
ठीक है. एंड यहाँ पे 200 बार रहता है, राइट? एक्चुएशन प्रेशर.
Yes.
एंड और क्या है? हाँ, ऑल दिस थिंग्स इन एमई, जैसे लुब्रिकेटर, फ्यूल पंप एंड एग्जॉस्ट वाल्व का एक्चुएटर. हाँ, all these three are controlled by a system which is called the CCU. ठीक है, तो यहाँ पे एक CCU हमने लगा दिया. What is CCU? It is the cylinder control unit.
Cylinder control unit.
हाँ, CCU. ये होता क्या है? This is a motherboard. ठीक है, ये मदरबोर्ड ही है, एक कंप्यूटर का मदरबोर्ड जैसा होता है. वो इसको सिग्नल देता है, इलेक्ट्रिकल सिग्नल, इसको भी देता है, इसको भी देता है, at different timings. So CCU is pre-programmed with an algorithm saying when it has to lubricate, when it has to inject fuel, and when it has to open the exhaust valve, depending upon the position of your lubricator, of your piston inside the cylinder. Depending on that position, it will open the exhaust valve or basically crank angle.
Yes.
Okay. But in MC, do you have CCU? No, you don't have, because these two are cam operated. Only this one is hydraulic operated. To control this system, there is something which is called HMI.
Yes,
Okay.
sir.
Yeah. HMI is very simple. It is human machine interface. All this is a fancy name hota hai. So inside HMI, you have basically two different systems. Okay. क्या रहता है? HMI split into
HMI में तो सर मैनुअली सर मैं कह रहे एडजस्ट मतलब कर सकते हैं सर, मतलब सिलेंडर लुब्रिकेटर इंक्रीज डिक्रीज मैनुअल.
नहीं, वो दोनों केस में कर सकते हैं, CCO वाले केस में भी कर सकते हैं. बट HMI फंक्शन इज बेसिकली स्प्लिट इनटू टू केसेस. ठीक है, एक होता है MCU, मास्टर कंट्रोल यूनिट, एंड देयर इज BCU, backup control unit. So basically फंडा यही है कि if MCU fails, your BCU will take over.
अब एसबीयू का क्या काम होगा सर?
किसका?
एसबीयू स्विच कंट्रोल यूनिट, वो तो बस सर चेंज करेगा ना? टोटल यूनिट में 3 होता ना सर, एएलसीयू में एमसीयू हो गया, बीसीयू हो गया, फिर एसबीयू हो गया।
आएंगे आएंगे उस पे। नहीं आप नहीं तो यहाँ पे सभी लोग कंफ्यूज हो जाएंगे इसीलिए आई डोंट वांट टू मेंशन एट दिस स्टेज, बट वी विल कम देयर। ठीक है, सो यहाँ पे एमसीयू है, बीसीयू है, विच इज सप्लाइंग द सेम सिग्नल, एंड दिस इज अ बैकअप ऑफ MCU. This difference between ME and MC you have understood. Is that clear? Any doubts until here?
No, sir.
यहाँ तक फंडा क्लियर है? ठीक है। Now I had promised you to tell you the function of the accumulator. ठीक है, तो यहाँ पे बेसिकली 2 एक्यूमुलेटर लगा रहता है, एक सक्शन लाइन पे रहेगा, एक डिस्चार्ज लाइन पे रहेगा। डिस्चार्ज के जस्ट बाद और डिलीवरी के जस्ट पहले। Okay, so there are basically 2 lubricators, which are lubricator nahi, accumulator, which are mounted in this kind of system. ठीक है, so यहाँ पे ये क्या करता है? What is the function of this accumulator? See, accumulator, what is the basic function of accumulator?
सर इट compensate some pressure sir up to 2.5 or maybe more sir.
अच्छा पल्सेस को एक्यूमुलेट करता है।
Okay, oh, but what do I achieve? But what do I achieve by having a accumulator? What if I did not have an accumulator? What would happen?
Continuous flow.
सर्जिंग
Continuous flow.
कंटिन्यूअस तो प्रेशर, इंजेक्शन प्रेशर मेंटेन करेगा sir.
Somebody said continuous flow. Can you elaborate?
Not continuous flow sir, continuous injection pressure.
Continuous injection pressure. Okay. See, the basic function of accumulator is to
Sir, accumulator.
reduce the pulsations in your line. Pressure fluctuations or pressure pulsations must be, nil. That is what the accumulator is achieving. Okay. Now, on the suction side, this is mounted that to ensure that the pulsation is 0 and lubricator is always filled up. Okay? It is always filled up. This is what it is ensuring. On the discharge side, there is a quill, correct? In the cylinder liner, there is a quill. So now you might have a back pressure or so. Again, there might be pulsations in the discharge line. So to reduce the pulses in the discharge line, there is a discharge accumulator. Suction accumulator will make sure that your lubricator is always filled up. It does not starve. There are no air bubbles. Okay. That is what these accumulators are ensuring. And how does the accumulator look like? It is a sealed unit with a diaphragm inside. Okay. So there is a diaphragm inside. So it looks like this. It is a sealed unit. There is a rubber diaphragm inside. Here is nitrogen gas. Nitrogen. And here is your lube oil. Okay. So the lube oil enters here and leaves here from the same pipe, which is from the same line. And here the nitrogen gas is always there. Okay. So basically this rubber diaphragm, it will, expand or contract depending upon the pressure fluctuations. So the nitrogen gas is basically taking your nitrogen gas, and the diaphragm is basically taking your pulses. It is taking the shock. Okay. In a MC engine fuel pump, do you have an accumulator? Has anybody seen?
MCC.
No, sir.
So what?
In a
What?
MC engine fuel pump,
Yes, sir.
there is an accumulator. Has anybody seen?
Yes, sir.
And where is it?
Shock absorber, sir.
Correct. In a MC engine fuel pump, the same function is being done by a shock absorber. It is directly mounted to your fuel pump. It is taking the fluctuations, fuel pressure fluctuations from your fuel side. Right? There it is called the shock absorber. Here it is called the accumulator. Construction is different, function same. Okay. Now, coming back to this system where the ME is there, here also there is an accumulator which is mounted here. यहाँ पर भी एक accumulator. Now, since this is a separate 200 bar supply, the pressure fluctuations will be there on the lube oil side, correct? So this is commonly mounted to your HCU. Okay. If there is fluctuation from this, or this, your complete HCU pressure, this 200 bar will be fluctuating. So that is why it is fitted on a common block over here. So there might be two accumulators, which is mounted to the common block. There can be one, there can be two, depending upon the size of the HCU. Is that clear? Any doubt?
Okay, sir.
Okay. Now let's go back to the system diagrams. So if somebody is asking you to draw this one,
Cylinder lubrication system.
then you draw this one. This is a much simpler way.
Very simple, sir. Yes.
This is very simpler. Whereas if you want to draw this one, this is also simple, but this is for a mechanical engine where you have the MCU, BCU, and other things. But I think the surveyor will be more happy if you draw this one. The reason being, here extra 2-3 things are shown here. The same thing, if you can show it on this particular diagram, then you can draw this one only. So what extra things that you have to attach here is given here. You see tacho signal, index signal.
Sir, the
alarm
screen
signal.
is not visible, sir.
Okay, hold on. Okay, so we were discussing about this one. I hope you can see the right screen now.
Yes, sir.
Okay, so this is for the mechanical engine. Okay, this is for the ME engine. But here the diagram is very simple, but 2-3 things are missing. What is missing? What are the inputs and outputs to this multi-purpose controller? That is basically shown here. You see, master control unit and backup control unit. So these are the inputs and outputs. Okay. So alarm system, this is an output. Slowdown system, that is an output. Tacho signal is an input. Index signal is an input. And one more thing is missing. Can you guess what is missing?
The sulfur percentage.
Correct. You hit a bullseye, man. So sulfur percentage is missing here. So they should have actually shown a sulfur percentage like this. Where to feed the sulfur percentage? It is inside the HMI panel only. But ideally, they should have shown this. This is also an input. So this is the input side. This is the output side. And these lines are the actuation side. Okay. Is that clear? Good.
Yes, sir.
The same things you can show over here. You can show, the tacho signal. Then you can show the load index. So this is the input, right? Output will be, you have the alarm, slow down, shut down, and the position feedback of that actuator. All this will be the outputs. Yeah. Is that clear? If you can draw these three things, then you can draw this whole diagram. So that will be your basic question in the MMD. What are the inputs and what are the outputs? Okay, draw a system diagram. Then what are the limits? And how do you know that your lubricator is functioning correctly? What would you answer for that? How do you know your system is lubricator is operating correctly? And how do you know that you are injecting the correct feed rate?
सर HMI पैनल पे सर शो करता है सर डिजिटल से वहां पर कितना मतलब वहां पर सर कंटिन्यूअस वहां पर डिजिटल शो करता है कितना सिलेंडर में कितना जा रहा है कितना ग्राम इंजेक्शन हो रहा है तो सर HMI पैनल से हम रेफरेंस लेके फिर मेकर के रिकमेंडेशन से चेक कर सकते हैं कितना इंजेक्शन होना चाहिए और कितना हम लोग दे रहे हैं तो इससे पता चल जाएगा
Okay, that is the right answer. That if
और
you have indications, you look at the input and output, no? And if there is no alarm, normally the cylinder lubricator, if there is any problem, it will give you alarm. Okay. So if there are no alarms, then it is operating correctly. It is as simple as that. So if there are no alarms, it means there are inputs coming correctly and the outputs going correctly. So
और
basically,
सर लुब्रिकेटर पर से सिग्नलिंग भी तो होता है सर लाइट बिलिंग बिलिंग करता है कंटिन्यूअस तो कुछ सिस्टमैटिक वे में फायरिंग ऑर्डर के अनुसार मतलब जो भी हो मतलब
correct. So you can, that is an additional indication, that red LED flashing light, which I told you about. So that is also an indicator. And what else? What will tell you, how will you conclude that whatever you are injecting into the cylinder is the right amount? Because see, lubricator will do what you are telling the lubricator to do. But what you are telling is right, how do you know?
सर फीड रेट कैलकुलेट करना पड़ेगा सर
कैसे?
बाय फार्मूला से फीडबैक से ग्राम पर किलो वाट आवर इनटू सल्फर कंटेंट उसके अकॉर्डिंग से हम लोग सर फ्लोर फीड रेट हम लोग निकाल लेंगे तो उसे मैच करेंगे कितना होना चाहिए तो फिर अभी कितना करंट वैल्यू मतलब इंजेक्ट हो रहा है HMI पैनल पर देखेंगे और उससे जो फीड रेट हम कैलकुलेट करके निकालेंगे तो उससे दोनों मैच करेंगे दोनों में ज्यादा डिफरेंस है तो हमें थोड़ा सेटिंग और बढ़ाना पड़ेगा एज पर रिकॉर्डिंग
Okay, but that is the theoretical method.
ये
But
theoretical
but in spite of putting the right formula, in spite of putting the right feed rate as you have calculated, your piston ring conditions are not good. Your liner condition is not good. What does it mean?
तो वो एसीसी फैक्टर बताया था ना कल आपने?
Sorry?
एसीसी फैक्टर सर.
Correct. I want you to remember and go back to the circular that we discussed yesterday. So there was something called a drain oil analysis. Remember that?
yes, iron testers.
So you need to do a drain oil analysis to establish the fact that yes, whatever I have calculated and whatever I am telling the feed rate to be injected is right. So take your
Okay.
drain oil analysis. Okay. Then you see the sulfur content and one more thing. What was that? TBN value.
TBN values. Yes.
So you
General
look at
TBN.
your, yes, you look at your drain oil sample and you get your iron content. Okay. Iron content should be within 200. Okay. And your drain oil analysis TBN must be within 10 to 20, 10 to 30. Then it is okay. That means whatever lubrication you are injecting is right.
Okay, sir.
That is the way of doing the assessment. Otherwise, you calculate something and you put the feed rate as something, and that feed rate will be, supplying to the cylinder. And, you cannot just sit like that and say, Acha, I have calculated it. There is a formula I have calculated. But is that calculation giving you results? How to find out without opening the unit? Is by drain oil analysis. So do the drain oil analysis. The alternative way of is to do a scavenge inspection. So at least every MAN recommends that every 500 hours of operation, you have to do a scavenge inspection. Did you do scavenge inspection?
Yes, sir.
क्या किया scavenge inspection?
स्कैब इंस्पेक्शन में सर आफ्टर क्लीनिंग से पहले से कितना पहले चेक करते हैं कितना स्लज एक्युमुलेशन हो रहा है वॉल पे सर. बहुत तो उससे से हम लोग फिर और स्लज को सर हम हाथ से टच करके भी देखते हैं कि अगर उसमें कुछ एब्रेसिव पार्टिकल्स या अगर बहुत ज्यादा हो रहा है तो मे बी चांसेस
क्या
लाइनर
बात
को
है,
डैमेज.
ये तुम बाबा बाबत है क्या यार? टच करके कितना अब्रेसिव है बता दिए.
ये नहीं से
See,
बस सर्वे के लिए कहीं कहीं लिखा हुआ तो पढ़ा दो.
your sludge is always abrasive. How can you touch and say this is more abrasive and this is less abrasive? It is like being an astrologer, right? मंगल को ये भारी पड़ेगा, शुक्र को वो भारी पड़ेगा. तो ऐसा नहीं कर सकते यार. तो basically when you are doing a scavenge inspection, see there are certain things to see. I will send you the MN circular for that one also. They have explained it very clearly. So you look at your piston rings. Okay. Let's start from your top land. So if you look at your top land area, if there is a lot of carbon accumulation, okay, it means, what does it mean?
सर एंटी पॉलिशिंग रिंग सर नॉट वर्किंग प्रॉपर्ली.
Correct. Now I will ask one question to each of you. So Kumar has already answered. Chalo. Anti-polishing ring is not working if the top land area has carbon. Now, if you look on the crown, okay, and the crown is wet, what does it mean?
Leaky fuel also.
Sir, either lube oil or fuel oil from injectors or exhaust valves.
piston sir, crown sir, crack sir, some while cooling while say leaking from sir.
Yes, all the three possibilities that you told is possible.
maybe
So fuel valve may be leaking. Okay. Lube oil may be leaking from the crown. That is why when you do the scavenge inspection, always make sure that your lube oil pump is running. So you can pressure test the piston, right?
सर क्रैक्स इन लाइनर भी बोल सकते हैं क्या? पानी आ रहा है.
अगर लाइनर क्रैक है तो पानी रहेगा, बट नॉर्मली यू सी फ्यूल ऑयल, लूब ऑयल, दैट मीन्स फ्यूल ऑयल इज कमिंग फ्रॉम द इंजेक्टर. Lube oil may be coming from the piston itself. And if there is water, then it might be coming from the liner. So that is this. These are the things you should notice. Okay. Now let's go to the piston rings. What would you check in the piston ring in a scavenge inspection?
सर पिस्टन रिंग सर मूवमेंट चेक करते हैं सर ग्रुप्स में, अगर वो फ्रीली मूव कर रहा है कि नहीं कर रहा है। और जब हम सर
अभी मेरा मन कर रहा है कुलदीप आंसर करे.
Voting.
कुलदीप इज क्वाइट.
पिस्टन को अप डाउन करेंगे तो सर लीव वाल सर उस पे सर टच होके स्प्लाइसिंग होता है।
कुलदीप, Kuldeep, are you there? You are mute. Kuldeep not replying. Okay, let's go to Kumar.
यस सर। सर सर पिस्टन रिंग का मूवमेंट चेक करते हैं सर ग्रुप्स में, मतलब फ्रीली वो मूव कर रहा है, टर्निंग गियर एंगेज करके सर पिस्टन को अप डाउन करते हैं। वहां पर एक वहां पर इंडिकेशन भी होता है सर, लीवर वहां पर रहता है, तो वहां पर जब अप करते हैं तो स्प्लैशिंग मतलब कंप्रेस होने पर सर लीवर से थोड़ा सा बाहर आ जाता है सर, तो वो इंडिकेशन है कि मतलब लुब्रिकेशन मतलब ग्रुप्स मतलब कि क्लियर है, पूरा कार्बन डिपॉजिट से शूट से कलेक्टेड पूरा भरा हुआ नहीं है। और पिस्टनिंग ब्रेक है कि नहीं है वो भी हम हैमर से वुड वुड लेके एक वुड स्टिक है हैमर से चेक करते हैं। अगर साउंड मतलब अगर डिफरेंस ठक ठक कुछ अलग टाइप के साउंड होता है, टूटा ब्रोकन रहता है, तो रिंग को हम चेक करते हैं कि ब्रोकन है या नहीं है। और
Okay. और राघवेंद्र, any more inputs?
ये पिस्टन ब्रोकन चेक करते हैं सर, ब्रोकन 1 by 1 करके वही ये आप ये कुमार ने बोला ना सर कि उसको वुडन से ट्राई करते हैं। अगर ब्रेक ब्रोकन होगा तो सर वो पार्ट अलग हो जाएगा। और उसके बाद एक साइड में जो ग्रूव होता है ना सर, वहाँ पे उसको सर्कुलेट करके भी देख सकते हैं। तो अगर टूटा नहीं हो तो सर्कुलेट हो जाएगा, अगर ब्रोकन होगा तो वहां से वो पार्ट निकल जाएगा।
Okay. Anything else?
हाँ सर। एंड और वही सर वो ये आपका ये जो इसका आपका अप एंड डाउन करके सर मूवमेंट को उसका वो क्या बोलते हैं, अगर ये कहीं टच तो नहीं हो रहा ना, उसमें स्क्रैचेज आते हैं ना सर, वो
सर एक चीज और चेक करते हैं सर, बट क्लीन सर पेपर पे चल रहा है
अंदर अंदर कैसे नहीं है।
अगर रिंग सर अगर
कुछ बोल रहा
स्पेस
था.
In the scavenge inspection, we first of all they check this piston rings condition. And one more thing we can check this by seeing this piston ring surface. This lubrication is lubrication ठीक से हो रहा है कि नहीं हो रहा है, वो भी पता चलता है। पिस्टन रिंग का ड्राई है कि थोड़ा सा लिटिल वेट है, ये भी हम देखता है।
Okay. Okay. Swarnavir, any more inputs here?
सर पॉलिशिंग भी चेक करते हैं सर उसकी, और इंटेंशन देखते हैं सर।
And one more thing sir, on the top
बट क्लियरेंस भी चेक करते हैं सर, वो इंप्लीमेंट लेके पेज के और पेपर के ऊपर आते हैं और बाकी रूम में आके सर देखते हैं कि मतलब उसकी बट क्लियरेंस की कब ज्यादा हो रही है क्या, और जो प्रोफाइल जैसे पी बैरल शेप का क्या वो कुछ चेंजेस हुए हैं क्या सर उसमें।
You are
और
right.
ब्लैक पैचेस देखते हैं सर कि ब्लो पास हो रहा है क्या, वो सब देखते हैं अलग से। बाकी तो मूवमेंट बता दिया ऊपर नीचे का आगे पीछे का, तो वो तो ठीक है, तो ये सब चीजें भी देखते हैं मतलब।
Sir, if there
Mhm.
is micro seizures, then you can find some small grooves in the bottom part of the
Perfect.
rings.
Yes, yes. I was expecting that answer. After so long, somebody said. Okay. So you guys know the answer, but I will fine tune it. So this is what you check in the scavenge inspection. I will send you the circular, which will have very nice pictures. Please go through the pictures. So let's assume this is your piston. Okay. I am drawing only the one half with the grooves. The other half is replica, is symmetrical. Okay. So this is your piston ring. So there are multiple points that you check in the scavenge inspection, and most of the points, they are related to the condition of the piston ring and the liner. The remaining things, checking the skirt, the top land, the crown, it is very easy to make an assessment, right? So when you check the top land in this area, so on the top land, if you find that there is a lot of coke or carbon deposits, that means probably your combustion is not good, and your anti-polishing ring may be already worn out. If you find a lot of brown spots, probably these are high calcium deposits, then probably your lubrication may be excessive. Okay. Now, when the lubrication is excessive, then it has a tendency to make the rings sticky. It is possible. And if you have a lot of carbon in this place accumulated in the topland area, okay, and if you have a lot of cylinder oil feed, then both of them might be forming sludge and they will deposit into these grooves. Okay. You might see sludge in the grooves. If you see something like that, then if you see sludge in the grooves, it is time to go back to topland area and look at your lubrication. Okay. So that is one indication that your lubrication might be excessive or your anti-polishing ring might be not doing the job. Then now many people said you will check the piston ring if it is broken by a wooden hammer, and then that is right. That is what we normally do. Okay. Additionally, what you should do is take a feeler gauge, okay, and measure this clearance. Okay.
Yes, axial clearance.
So you have to measure this clearance. So normally this clearance is 0.3 to 0.6. Okay. If it is excessive, more than 0.6 or 0.8, then it is something concerning. You should check the reason why. Are you getting a wrong reading, or are you getting it is actually worn out? That you should see. Okay. Check at least 2 points by a feeler gauge. So that is one. And you should check for all the rings like that. Okay. The next thing to check is the profile of this ring. Normally the profile of the ring is like this. It is, nicely rounded off. The edges are nicely rounded off. If you see something like this, then this is not good. This is a sharp edge. Okay. This sharp edge is not allowed. If this sharp edge is there, then it is probably scraping off all the metal from your liner. Okay. So that sharp edge should not be there, and your clearance must be good, right? The next thing to check is the CL groove. You know what is CL groove, right? So if this is the piston ring, okay, on the side of the piston ring, there are cuts, oblique cuts.
Butt clearance.
No, that is not butt clearance. CL groove is different. यहाँ पे cuts रहेंगे. Okay, this is the butt. This is the open butt, but these are the CL grooves. So if you look on the side of the ring, I will draw like this. एक रिंग अगर ऐसा पकड़ लो तो यहाँ पे रिंग के प्रोफाइल में there is a cut, there is a depth, okay, like this. This is the front view. If you look at the top view of the same one, then you will find it is like this. Oh, sorry. How will it look? It will look like this. This is the top view. Yeah. So there is a depth which is here, and that is what is this cut. Is that understood?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now, when the ring is new, normally the depth of the CL groove, this groove is about, depending upon the engine size, but the normal range of a new piston ring is about 3.5 mm, ranging up to 5 mm. Okay, and the maker says in service, if this CL groove depth comes down to about 1 mm, then you have to renew the rings. So you should measure the depth by either a depth gauge or by a vernier. That you can do. You can put a vernier here and you can measure this depth of the groove. That you can do.
सर ये ग्रुप से इस दिया रहता है सर, एक्सेस से लुब्रिकेशन नहीं जाए इसलिए सर ना, माइल्ड वाइपिंग एक्शन, माइल्ड.
नहीं उसके लिए नहीं है.
किस लिए सर थोड़ा बताइए.
Do you have you heard about CPR?
Yes, sir. Controlled pressure relief.
Yes. So these are those grooves only. These are the CPR grooves, which is called the CL grooves.
What is full form CL group?
It is a
Controlled leakage, sir. Controlled
leakage. It is normally called CPR. Okay. But the maker addresses it as CL grooves. So the reason it is given is that it is not to have a too much pressure difference between your the first groove and the second groove, the second and the third. So it is a controlled, pressure reduction from very high peak pressure to low. Because if you have too much of pressure difference, then the rings may break. So here is too much pressure. And again, there is very less pressure. So, your rings might tend to break if there is a too much of pressure difference. So that is why that controlled leakage is provided through these grooves. And these are...
सर इसको काउंटरिंग और रबिंग फेस भी कहते हैं ना?
इसको?
इसी को सीएल ग्रुप काउंटरिंग और रबिंग फेस यही है सर ना?
Countering of rubbing face.
हाँ.
I do not know what that means. Where did you read it?
ये पढ़ा था डीएलसी फिल्म.
यार कभी दिखाना यार, बड़ा इंटरेस्टिंग है. बट
ठीक है सर, मैं भेजेगा सर.
Sir,
उसमें लिखा हुआ था माइल्ड वाइपिंग के एक्शन के लिए तो अवॉइड द एक्सेस लुब्रिकेशन पासिंग थ्रू द कंबशन चेंबर, ये बोला था उसमें.
for excess lubrication, I have no idea about that.
Sir, will this controlled leakage grooves provide sealing for the second rings?
they do not provide a sealing for the second rings, but in fact, they avoid a lot of pressure difference.
Okay.
So that is the only function of these groups. Because what happened in the smaller engines, in the older engines, the Pmax was very less. Okay. So you did not have the need of having these grooves. But as the peak pressure increased, the material remained the same, right? So what happens is that if you have a liner here, the piston ring seals like this, right? So you have a pressure here, it goes to that behind the piston ring, and then it pushes the piston ring here, correct? So this one seals here. That is how the piston ring works, correct? The piston ring basically expands. Now, if there is too much of peak pressure, this will be sealing really tight and additional friction will be there. That is because the pressure here is very high and here there is very less pressure. So if you provide a cut here, the pressure will leak through these grooves, go to this particular chamber, and excessive pressure will not be here. It will still seal, but not with the excessive friction. That is the very basic funda of having a seal groove. Is that understood?
Yes, sir.
Yes, sir.
So you check the depth of the seal grooves during your scavenge inspection. And if happens to be 1 mm, then definitely it is time to change the ring. Okay, that is what the maker recommends. And the next thing that you are going to check is the sharp edge. Sharp edges you can see by your naked eyes, and you can have. Now the appearance of the ring must be bright and smooth. Okay, it should be bright, looking bright. It should not be looking dull. It should be looking bright, and it should be looking smooth. Now, how do you distinguish this is smooth? It may be smooth for you, but not smooth for me, right? So what it means is you should not have scratch marks like this. If you see this scratch marks, these are basically micro seizures. That means आपका lubrication sufficient नहीं है. That means you should increase the lubrication in stages. Okay. So normally if the lubrication is 1.1 or 0.8, then you increase by 0.1. That is what is the recommendation. Or directly, if you see so much of things like this happening, you open the manual, it is very clearly explained that you increase the feed rate to maximum of 1.2 and keep it like that. 1.2 gram per kilowatt hour, you should straight away increase if you see scratch marks like this. And you should wait for this to recover, and maybe it may take 100 hours, 200 hours, 300 hours. You should wait for it to recover. It should ideally recover. But if it doesn't recover, then high chances that it will go and scuff. In that case, you have to change the liner or the piston ring. Too much complications. So that is why every 500 hours you inspect, and it should be bright and smooth like this. Okay. So that is one thing. The next thing to check is that not every company, but some companies, they insist on checking the coating thickness. So now with the new design of the piston rings, it is an instruction from the maker to install the cermet coated rings in all the grooves. Okay. So this is a circular back in 2014 or 16 somewhere, that all the grooves must be now cermet coated. And there is a coating thickness meter. If your company has already provided it, then by the coating thickness meter, you have to measure the coating thickness of the cermet. So normally you get a reading of 200 micron to 300 micron. Okay. If you see the cermet is 10 micron, 20 micron, then you should be super careful. Okay. It does not mean that you have to go and change the rings, but then you have to make your inspection frequency better, just to check if it is not going and scuffing, because the cermet, if it is not there, then the rings are just, piece of iron. Okay. It has a tendency to get sharp. So if you have a coating thickness meter, then this coating thickness must be measured and recorded. Normally 200, 150 to 300 is fine. For a new ring, it may be 400, 600, like that. Okay. That is one thing you can check. And the other thing that you must check is the liner. Liners should have honing marks. The wave cut pattern that you see on the liner. Have you noticed?
Yes, sir. I'll be stick there.
So if you see a wave cut pattern which is on the liner, then it is a good sign. If you see liner like a mirror, not good.
Polish.
Then it is polished. If there is no wave cut, now there might be cases where near the scavenge port, you will see that it is already polished. And here you will see the wave cut. So now what to do? Now this is a normal phenomena because near the scavenge port, it is already very cold. And there may be moisture accumulation, due to which the lube oil film is not very effective. Also, the piston is slowing down. Okay. So the friction will be a bit higher. So that polishing is normal. You don't have to do nothing much about it. Okay. You can check your air cooler efficiency. If the air cooler is not condensing all the water, then probably you will have a lot of moisture coming into the liner, and slowly that liner will become fully polished. So you should check your air cooler also. How will you check your air cooler? कैसे चेक करोगे?
सर उसको ओपन
can
कर
you
fins को चेक.
But what will you do looking at the fins?
can you repeat the question once again?
How will you know that your air cooler is functioning correctly?
So अगर if water carrier is there, then your scavenge space will be purely clean.
Sir, inlet outlet temperature of water.
Inlet outlet temperature दिए तो check.
Correct. Inlet and outlet temperature.
Inlet outlet temperature manometer is
And
also
that there is a mountain and manometer is there.
Correct.
So from manometer we can this pressure drop. How much is pressure drop from this inlet air pressure drop, and it's going to the scavenge pressure, like that. We can understand this cooler.
That is the very right answer. But I will give you one
and
cross question.
also drain is there, no sir. Excavation drain is there.
From the scavenge drain?
So side glass is there, no sir. Yeah, excavation drain also, and
वो तो इंजन रूम का टेम्परेचर बट
ब्लोअर साइड से जाता है ना. सर ब्लोअर साइड से जो जाता है उधर भी एक ड्रेन रहता है सर, उसमें जो साइड ग्लास नीचे रहता है सर, तो वहां से भी
सब सही है. These are the arrangements, but my question is different. My question is, how will you make a judgment? My air cooler is now good. I don't need to do anything on the air cooler. So somebody said inlet outlet temperature. Agree.
Uh,
Somebody
okay.
said pressure
Exchange
differential.
pressure is okay. Maintain. Exchange pressure is okay. Then air cooler also is good.
ये रिलेशन नहीं
Hmm?
See, my question is simple. Is my air cooler doing what it is supposed to do? So somebody came very near to the answer, saying inlet outlet temperature. Another fellow said YouTube manometer. Yes, but looking at YouTube manometer and looking at inlet outlet temperature, how do I judge? Okay, now nothing to do, or I should take some action. What is the right point?
सी बटा इनलेट आउटलेट टेम्परेचर
Okay. So looking at seawater temperature, what should I do?
if the temperature is if temperature difference is good, sir, if temperature difference is very less, sir, so maybe it chalks at tube sir cooling.
Baba, we are engineers, so we need to quote how much temperature difference, how much pressure difference.
In this air cooler, the pressure difference also depends on the engine RPM, sir. When it's
Correct.
running in the full turbocharger RPM, so if
Correct.
sometimes it is 120 to 140 mm column, and that
Correct.
if we air cooler inlet air temperature 120, then we are maintaining the scavenge temperature near to 40 to 45. So in the normal condition, if we give this 120 air temperature inlet, if my cooler is efficient, then outlet temperature it should maintain below 40 to 42. Then we have to adjust. If it is not good condition, then our outlet of the cooler temperature it will increase gradually, and within short time it can increase very rapidly. So,
Is there any other answer? Because you all of you are getting close to the answer, but missing out something which I want you to really understand.
कंट्रोलर
भाई बोलते हो तो पूरा बोलो कंट्रोलर बोल के नहीं समझ में आता है. You may be right. Just speak your mind, man.
is there something related to scavenge air pressure?
See, I'll tell you what happens. Everybody is telling scavenge pressure, scavenge temperature, pressure difference, temperature difference. Yes, it is the right thing, what you are saying. But what I want you to understand is the actual dynamics of, if I see a temperature difference, let's say engine is running at 50% load, okay? And scavenge temperature is 40 to 43 degrees, okay? Now, being a engineer, if I see engine is 50% load and I'm writing in the logbook 43 degrees Celsius, do you think I should take some action or no? If I have to take an action, why? If I don't have to take an action, then why not? How do I come to a conclusion saying, okay, this is good, no need to worry?
For
So the
40% load, that scavenge temperature comes to 42. That means something is wrong, but it is very low load condition. So inlet temperature also, air cooler also very less.
okay,
So
at
it's in my
100% load, let's say I'm running at 100% load and my scavenge temperature is 42, 43. Is that good or is that not good?
sir, the less scavenge temperature, it is not good. It's lead to the sir, what is called cold corrosion or surface corrosion, because this moisture can be present in this there.
But now you have 0.5% sulfur cap, right? So where is the sulfur now? If you are running on diesel oil with 0.1% sulfur continuously, you are continuously operating in Ika area. Where is the sulfur? Where is the cold corrosion? So if I'm running at 100% load, my scavenge is 43 degrees. Can I say, wow, this is wonderful?
Sir, because sir, we need to have this combustion temperature also. Air temperature is 42, and it's very close. मन temperature थोड़ा ज़्यादा रहेगा तो combustion temperature मेरे को लेके आने में ज़्यादा तकलीफ नहीं होगा.
See, I'll tell you the answer. So whenever you go on board and somebody tells you, then even in MMD, okay. See, nobody is a magician. Everybody has to refer to the engine manual. Then I can say, if the parameters match the engine manual, then definitely there is nothing to do. So even when I match engine manual, something which we never do and we should always do is something called a ISO correction. This is what I wanted you to know. Okay. So what is a ISO correction? Let's say my manual says, this is my manual. जो जिंदगी में कोई कभी खोल के देखता नहीं है, कुछ टूट जाता है तब जाता है खोलने. Okay. So this is the load. Okay. And this is the parameter. So I'm just taking one parameter. Let's say scavenge temperature. Okay. So this is the load, 10%, 20%, let's say 25%, and then 50%, 75%, and maybe down below is 100%. Okay. Now, from this table, I can find out what is the scavenge temperature at 10%, 25, 50, and 75. Correct? Now, this is my engine. Okay. When my engine is running at 75%, and let's say the scavenge temperature is 43, let's say. And if I see 43 degrees Celsius, should I be happy? %, 43 degrees. Now it is running at 75%, 43 degrees. Should I be happy?
Because this parameter is matching to the rated parameter. Obviously, it is good for the engine.
So I must be happy. Whereas I have a different opinion. So my opinion is, all these parameters which the maker has given you in the engine manual, this is at an ambient temperature of probably 22 degrees Celsius, which was tested during the sea trial in the yard. Okay. Maybe 25 degrees Celsius, maybe 22 degrees Celsius. Some shipyards, when they tested it, the ambient temperature was 18 degrees Celsius. Okay. So let's assume all this test in the manual was done at 22 degrees Celsius. Okay. My engine is now operating at 10 degrees Celsius. Right? Now, at 22 degrees ambient temperature, at 75% load, my scavenge temperature was 43 degrees Celsius. Here, the actual condition, I am at 10 degrees ambient temperature, 75% load. Should my scavenge temperature be better? Do you think? It should be better, right?
Yeah, it should be better.
It should be better. So just by looking at this and matching this one, I cannot be happy and say, अच्छा, अब तो कुछ करने को है ही नहीं यार. Okay. So that is why, to make a judgment, you should do the ISO correction. What is the ISO correction? So there is a standard defined in the ISO standards. The ambient temperature is rated as 25 degrees Celsius. Okay. And the ambient pressure is about 1001 barometric pressure. Okay. So basically, you should correct your temperature in the manual to ISO standard, and also this temperature to ISO standard. If they both are the same, then actually you have nothing to do. You are performing as required. I will tell you another example. At 75% load, 43 is the scavenge temperature. Your engine is running in the tropical weather. At 75% load, okay, your scavenge temperature is 52. Should you be worried? If yes, why? If no, why? To know that, you have to correct this to the ISO standard and see. You have to correct this to the ISO standard and see. If both are the same, then there is nothing to worry. There is nothing wrong with the engine. You can't do much. Do you understand this? दोनों को एक प्लेटफॉर्म पे लाके कंपेयर करो. Because here the ambient temperature might be 36. Okay. Your engine was tested at 22. So this is the difference. How can you bring 36 degrees and 22 degrees in one platform and compare? Is by doing a ISO correction. ISO correction has a formula for correcting the temperature and correcting the pressure. To bring it, both the platforms, I mean the engine and the manual parameters, bring it to one platform, and then you make a decision. Do you understand what I'm saying?
Yes, sir.
Okay.
It is the batsman thing. You were saying that this is the sea trial condition, and while selling condition, there the both conditions are different. So
it will always be different.
For that, there will be parameters can be changes, because for that they have come with the ISO correction standard. So
Yes.
whenever these parameters we have to correct, we need to correct or adjustment the parameter. So we have to follow the ISO standard. यही सर आप बोल रहे हैं ना?
Correct.
ठीक है सर.
So if you compare on the ISO standard, and if you correct 43 degrees to 25 degrees here and 52 degrees, and it turns around the same after putting the correction, then definitely engine is performing as it should perform, right? So just by looking at the pressure and temperature and other things, you cannot say the engine is good or bad. You have to make a ISO correction. Only then you can comment that the engine is good or bad. This is what the surveyor will expect. Okay. So normally after taking main engine performance, drain oil analysis, ये सब करने के बाद में, when you record the parameters, is that parameters good or bad? That will depend after the ISO correction that it is matching the manual or not. Do you understand?
Yes, sir.
Only then you can comment that your engine performance is good or engine performance is not good. Same goes for generator also. Okay. Yes.
Yes.
Right. Then I will send you some study materials for alpha lubricator, what we discussed yesterday, the circular. And one more thing that I wanted to send you is this one. If you can see my screen, hold on, I'll share the good one. This. So this is a alpha lubricator system not like a manual, but it is a good explanation of, what it is and what is the maintenance that you should do and some other points. Whatever is there, we have already discussed. Okay. But the surveyor will be asking you very simple things. This is very extensive. This is the whole manual. So don't have to read too much into this. Okay. Two things I want
I
to.
think this lubricator is for the MCC engine.
MCC engine. Yeah.
Yes. Yes, I have read this manual in my same manual.
Yeah. So this is for the MCC. For a ME type, it is different. Okay. So what I want to discuss now is two things, very common questions which are asked. Is that the first thing, at what angle or at what position of the piston does the lubrication happen?
Repeat again, sir.
At what position of the piston the alpha lubricator injects
Sir,
the
it will
oil?
inject, sir, sir, lubrication will happen, sir, during compression. So when the piston ring passes, when two piston ring passes from the, I mean, sir, crossing quill, sir.
In between top ring and that second ring, we are injecting this lube oil inside
During
this.
compression, sir.
See, during compression stroke, okay, when your first ring is passing the quill, then
Quill.
the lubrication will,
Inject.
the quill will be injecting.
Inject.
Okay. So that is one very common question which is asked.
Sir,
The second question which is asked, if lubricator fails, okay, what is the what is going to happen? So if there is a alpha lubricator failure,
alarm will come, please.
then what is going to happen and what are you going to do? Okay, let me put the question in a different way. You have a mechanical lubricator. You have a mechanical lubricator and the lubricator has failed. What are you going to do?
The manual कुछ करूँ
कितने देर भाई?
अगर इमरजेंसी है सर मैनुअलिंग में तो करते रहेंगे उसके बाद तो रोकना ही पड़ेगा.
करेक्ट.
वो सर आरपीएम रिड्यूस के फास्ट वो तो स्लो स्टॉप करके ही चेक कर सकते हैं सर.
बट फाइनली क्या करेंगे हम? लुब्रिकेटर ही चेंज करेंगे. करेक्ट.
स्पेयर होता है ना सर हम लोग के पास.
करेक्ट.
फाइनली लेकिन स्टॉप करके ही चेंज करेंगे ना स्पेयर भी.
हाँ स्टॉप तो करना ही पड़ेगा. ओके, इन मैकेनिकल लुब्रिकेटर
उसको स्क्रू ड्राइवर से लूज कर देते हैं, ज्यादा ऑयल देते हैं सर उस टाइम पे. ये भी करते हैं सर इमरजेंसी टाइम पे तुरंत
in a
लूज करके और
mechanical
ज्यादा ऑयल.
lubricator what you do is you manually press those quills, है ना?
Yes.
There is a special tool, compression tool type का, वो T bar जैसा रहता है. And you go and start pushing those quills manually.
In mechanical, sir, only.
In mechanical.
Okay, sir. What about ME, sir?
So in ME, what happens is, see, this is a very vague question to ask when you relate this to alpha lubricator, because in alpha lubricator you saw there is a actuator here. ठीक है, यहाँ पे actuator है, piston है, there is a solenoid, there is a electrical connection, and there is a hydraulic connection. Now, if somebody has asked you, कि alpha lubricator has failed, what is your action? You cannot say that I will go and change the lubricator, or I will, do these things. So first you should identify what kind of failure is here. Is it an electrical failure or is it a hydraulic failure? Correct. Because if the failure is electrical, which is from the control system, even if you change the lubricator, nothing is going to happen. The new lubricator will also not work, correct? Do you understand what I'm saying?
Yes,
Yes,
sir.
sir.
So you should identify ki bhai, where is the problem? Is it an electrical problem? Is it a hydraulic problem? Is it a mechanical problem? What is happening? Okay. So you should identify. So let's say it is an electrical problem. So the problem is with probably the control signal,
night.
which is control signal, which is coming here, or probably with the solenoid, or there is a position sensor, feedback sensor. ठीक है? Now, these three could be the problem. So you should identify which one, right? If it is electrical and if you can solve it just by replacing the solenoid, problem solved. Okay. If it is a mechanical problem, then you have to replace the lubricator.
Okay, sir.
Okay. Now, normally from the yard, okay. So I told you about CCU, right? Cylinder control unit in ME. So every unit will have its own CCU. Okay. So unit number 1 will have one CCU. Unit number 2 will have one CCU. Unit number 3 will have, 4 will have, and 5 will have. Let's say this is unit number 1. Okay. And this signal is coming here. Okay. Let's say there is a problem with this signal. So the yard normally gives you a backup cable. And the backup cable can be attached to any one of the other CCU, and the signal can be provided from the other CCU. Is that clear?
Yes, sir. Clear, sir. For backup system.
So there is a backup cable which is provided from the yard. Now, when you use the backup cable from the other CCU, okay, your lubrication may not be perfect because this CCU is sensing the TDC of this unit, whereas my failure is in some other unit. So TDC of this and TDC of this may not be the same, right? So it will be randomly injecting, okay, at any position, but you will not at least lose the lubrication, and you should consider replacing this CCU or MPC or the wiring as soon as possible. So that is the backup arrangement. Okay. So that is one. The other thing is, if any problem happens with the alpha lubricator, the stroke is by default set to the maximum stroke. Okay. The stroke will not be controlled. It will be pumping maximum oil. So maximum stroke, it will go to the maximum stroke. Okay. So these are the arrangements. Is that clear?
Yes, sir.
Clear.
Yeah. बस इतना ही है. So I will send you the materials. And it's almost midnight, past midnight for me. So yeah, let's call it off. And tomorrow we'll gather again.
Sir, tomorrow, sir, we will discuss the question and answer, sir.
Tomorrow questions answer, yes, it will be very nice and easy for me if you can
Yes, sir.
put 5-10 questions in the group on, and we can concentrate on that.
Okay, sir.
Yeah, please do that.
और सर मैं ग्रुप में पूछना सर, अभी किन लोगों का MEP मोटर है अभी? स्वर्णवीर आपका भी है क्या?
मेरा तीनों है, मेरा सारा है.
क्या?
खाली मेरा इलेक्ट्रिकल हुआ है.
नहीं, अभी इस मंथ में कौन सा आपका पेपर है क्या?
नहीं है, हो सकता है मैं भी दे दूं, मैं पूछ रहा हूँ.
नहीं, इस मंथ में अभी तो आपका डेट तो आ चुका होगा ना, या जो भी?
नहीं, अभी नहीं दिया मैंने.
अच्छा, अभी नहीं दिया. ये बाकी 2 लोग का तो मालूम है मेरे को, कुलदीप और जेपी.
George, when are you giving your oral, man?
So this month only, date has not yet come.
Okay. Okay, perfect.
Okay, sir. Thank
Okay.
you.
Okay.
Thank you, sir.
Okay, then we'll see you tomorrow, man.
Okay,
Thank you,
sir.
sir.
Okay, sir. Good night.
Good
Bye.
night. Bye.